Let's look at the properties of y equals sine theta, or in some cases y equals sine x. So first of all, domain. Well, you can see that the graph for x can be anything. It can be negative values, it can be positive values. So it's actually the set of real numbers. So that's what we're going to put for our domain. So our domain is x as an element of real numbers. Our range, well, we also are in real numbers, so that's not a problem. But we do have some restrictions on y. Because the unit circle, it falls between -1 and +1, our y has to fit in between there. So between the lowest and the highest spot. Okay. Now our maximum value, well, that's pretty easy. Our maximum value is 1. Our minimum value is -1. And what we mean by important x values, these are the places where the maximum and minimum values occur. Now, I don't know if you notice, I started when I did actually put with our table of values, we did 0, 45, 90, 135, and then after that I skipped. And the reason I skipped is the important x values that we're concerned about are with the places where the function is either at 0, which is at 0, 180, 360, or where it's the highest point or the lowest point. And that occurs every 90 degrees. So the important x values are 0, plus or minus 90, because we could go 90, positive or negative, plus or minus 180, plus or minus 270, plus or minus 360, and we could keep on going. Okay, so those are where the important x values that we're concerned about. Okay, so now let's look at the graph of cos. Now, again, I'm going to go to that applet and take a look at it. Okay, so when we go at it, this time we're going to choose cos, which I've done. And remember, the green is as we go around the unit circle. But notice what happens to the graph. Where does it start? Well, we know on the unit circle, the cos theta, its trig values deal with the x-axis on the unit circle. So if you notice what happens, we're looking at the pink. Okay, notice the pink is getting smaller and smaller until we get to 0, which happens for cos at 90 degrees. And then what happens, we know from cast that cos is negative in the second quadrant. And notice the graph is going negative. Okay, and then it stays negative, but the numbers then start to get larger again until we get to 270. Okay, and then we know in the last quadrant that cos is going to be positive again. So notice what happens. It becomes positive again. And you're probably wondering, what on earth is that red? Well, we'll look at the red afterwards. Okay, so there we go, and it gets back up to its starting point. So its stencil, again, is 1 revolution around the unit circle. So its period, if we wanted to look at it, is 360 degrees. So let's go back to our note again. And again, if we look back at the unit circle, we notice that the important points were at 0 for the theta values at 90, 180, 270, 360. Okay, notice they're not pointy, they're nice and rounded as well. Okay, so that's what we're going to put down in our table of values. So remember that this x is theta. So if we choose 0, we know that the cos of 0 degrees is 1. Then if we look at the cos of 90 degrees, sorry, that should be 1. It is 0. At 180, we're at -1. At 270, we're at 0 again. And when we get back to 360, we're at positive 1 again. So we're going to transfer these numbers. So we're at 0, 1, 90, 0, 270, oops, sorry, I forgot 180, 180, negative 1, 270, 0, and at 360 we were at 1 again. And again, if we kept doing it every 90, the pattern keeps repeating itself. So we could keep on going and going in actually either direction. Okay, so we actually have our points. I almost think of them as ping pong balls where I fit in between the positive 1 and the negative 1, and every time I cross one of those important x values, I have to put a point. Okay, and that's kind of what's happening. Now you can see my cursor's not going where I want. Okay, so let's see. That's not very smooth. And I'm doing not too bad on the computer. Do much better. I would do a much better job if I was using chalk or something. Okay, so that gives you an idea. It looks very, very similar to the sine one. And let's see if I can actually take it. And I'm going to copy it, and I'm actually going to put it over here. And I'm going to change its color, and so we can actually see how it's the same and how it's different. So this is the cos one. I just took it. And uh-oh, look, it's very similar to the sine one. In fact, it is very similar, and we'll talk about that relationship in a moment. Okay, so I'm going to actually get rid of that now because I don't need it. And we go back to our cos. So let's finish doing the properties of cos. Again, x can be any real number. Okay, and I need to put an arrow on this side. I put it at the other end. So the domain x is an element of real numbers. Y is an element of real numbers such that, again, we have y, it is sandwiched in between negative 1, its lowest point, and positive 1, which is its high point. So we know our maximum value is 1, our minimum value is negative 1, and the important values, guess what? Exactly what they were for the sine one. Okay, again, it happens every 90. Different things happen every 90, but 270, 360, plus or minus. And the pattern continues and continues and continues. Okay, so let's take a little bit closer look at it because the note actually, what you're going to write down is pretty much finished. So we can see that it acts like a ping pong ball fitting in between, and that happens for cos. It also happens for sine. It ping pongs in between the 1 and negative 1. Okay, another thing, when you saw me put the cos graph on the sine graph, they look very, very similar. And actually, if I go back to that applet that we were looking at, that unit circle applet, and I'm going to reset it, and I'm going to make it graph sine and cosine at the same time. Now, sine, remember, started at 0, 0. Cosine started at 0, 1. Okay, now as they are graphing each other, you can see that the two graphs do intersect at certain locations. However, they're slightly different. Okay, so when cos is at its high point, sine is in the middle. Okay, when cos is at its high point, sine is in the middle. So they're alternating back and forth. So it's creating actually a really quite nifty looking graph. Now, as soon as it's finished, I'm going to actually then graph tan, and we'll find out what's going on with that tan, because the tan is, remember, tan equals sine theta over cos theta. And because it's made of those two graphs, obviously tan is related to them. So we're almost finished here, and we're almost around that unit circle, and you can see that it's just the one graph is actually shifted compared to the other one. Other than that, they're pretty much the same. Okay, so I'm going to reset. This time I'm getting rid of sine and cos, and we'll look at tan. And when tan does it, tan is that red line. So notice what happens as we go around, that tan is actually going higher than what our sine and cos did. And it like just goes right off and then it flips back down again, and notice it's coming down on the bottom of your screen. Okay, it's crossing again, so I would assume that it's going to then spike up again on us, and I think that's what's going to happen. But then what does it do after it goes to the top? Let's find out. It'll soon be there. Sorry, I can't make it speed up any faster. It just won't do that. And it's going way, way up, and then notice it's starting to come back up again. So really what's happening here is these places where it's going up and then coming back down, actually there's asymptotes located at those locations. So in this case, there's an asymptote at 90 degrees and at 270. Now the reason that happens is because sine tan equals sine over cos. And cos, in the locations of those asymptote lines, cos is 0. So it means I would have a sine divided by 0. And we know we can't divide by 0 in mathematics. So that's creating those asymptote lines in those locations. As I said, in grade 12, you study the tan graph in a lot of detail. So that just gives you kind of an outlook before you see it next year. Okay, so that's it for the lesson. Have fun with the work.